Everyone, in this video I'll be demonstrating the chain abstracted solution being built at Etherspot, which was also a part of DevCon 2024 presentation. I have my React app up and running over here, so let's get started. I have my connect wallet option over here. Let me just connect my EOA account. I'll just say connect. Now I have successfully connected my EOA account to this website. And also as a part of this demo, the EOA account, whatever I connected right now, has a associated modular smart wallet already deployed for the chains whatever I'll use. And this modular account is compatible with EIP 7579. And as you can see, I have my modular address displayed over here, and I have my balances loaded here. This is the unified chain abstracted balance across both of the networks. Uh, for the sake of this demo, two, we have chosen Sepolia and Base Sepolia to serve as source and destination chains, and we will be doing a chain abstracted token swap where we will be using a combination of assets on Sepolia to get a different token on Base Sepolia. So as you can see, this is my balance screen over here. If I can just expand this, out of 520, I have 500 on Base Sepolia and 20 over 500 on Base Sepolia and 20 on Sepolia. Uh, Also, as a part of our solution, we are using a custom validator called Credible Account Module, which basically manages the locked assets and stores locked tokens for each session key which we create against every smart contract wallet. So one more point worth noting here is that so that we lock the tokens whenever we express an intent. Whenever we express a swap intent, we lock the tokens whatever we want to use on the source chain, so that those tokens are locked over the smart contract wallet itself, and they are not moved anywhere else, so that the tokens are never moved out of the smart wallet. And then the session key whatever we create when we express intent, only that session key will have access to uh, you know access those locked balances. So now we will try to express a swap intent where we desire to have mana tokens on base Sepolia by dispensing a combination of USDC and USDT on Sepolia. So let's just keep a note of balances over here. I have 20 USDC and 20 USDT locked on uh, already locked, and I have 38 mana tokens. So that's 20, 20, and 38. Let's just go ahead and express an intent. So this is a basic UI where we intend to capture the user's intent. Unlike the finished article, here user will have to choose the destination chain and specify the amount of mana tokens to be received. So I'll leave the source chain as Sepolia, and I'll choose destination chain as base Sepolia, and I'll say I want mana tokens. I'll use both USDT and USDC. As you can see, my net balance changes as I select either of these tokens. This net balance is something which is your actual balance on your smart wallet minus whatever you have already locked. So I'll just say I want to use both of these tokens and I want to get a mana token. So here now we are expressing an intent saying that my desire is to have a mana token and I am ready to spend both of USDC and USDT. I'll say I want to spend $10 worth of both combined USDC and USDC and USDT, and I want to get maybe let's say 12 mana tokens. Now I'll go ahead and submit this. So our solution uses Suave as an intermediate to register the user intent and allows the solver to read, solve, and prove back when they have executed the user intent successfully to claim their locked funds. Solver actively listen to all of these express intent actions, and then they process it and give us back a solution. So now for simplicity, we only have one solver integrated here, which has responded back with a solution to us. So as per our selection, as you can see, we have 5 USDT and 5 USDC, which we will be spending to get 12 mana tokens. The $10 whatever we specified in the previous screen has been split into 5 USDT and 5 USDC. Let me just go ahead and submit this. Uh, when I submit this, this will result in two transactions and a signature request, where in the first transaction we create a session key pair on Swap using a confidential compute request, which will make use of a special storage called confidential storage, which is a secured enclave of the trusted execution environment, and it stores the information in the key value format, and it's encrypted using Swap. So and on the second transaction, we have a signature request for the second transaction, where we actually lock these assets whatever we are using on the source chain, which is 5 USDT and 5 USDC. So this is the signature request for that. I'll just confirm this. And I'll let the transaction to go through. Uh, Now, once the transaction goes through, so these are the two transactions which I was talking about. The first transaction is on Swap, where we actually created the key pair, and using that session key pair, whatever we created here, we use that to lock funds on top of it. So whatever funds we lock on this transaction is only accessible by the session key, whatever we created here. So yeah, and now we wait for the bid to actually execute to receive the mana tokens. So yeah, as you can see, the bid has been successfully executed. Let me close this to check if I have received mana tokens. Yeah, this was 38 before and it became 50, so we successfully received 12 mana tokens, and both of these were 20 each. Now this has become 25, so we have successfully locked 5 tokens each on five tokens of USDC and USDT respectively. So now solver can make use of the session key, whatever we created in this transaction, and claim back their funds according to their convenience. Yeah, that's all for now. Thank you.